So yeah, again, I'm super excited to welcome everybody here today and kick off today's discussion with Dr. Christian about the practice problem 2 topic of space exploration. And just for those of you who are brand new to this topic, I'm just going to go through a very quick synopsis of what space exploration is. So space exploration challenges humanity to push the boundaries of knowledge, technology, and cooperation. Oh, sorry. I think the slideshow.
Mahi, did you have the slide deck up still?
Sorry, I don't know what happened. There we go.
Thank
Okay.
you.
Um, okay. The quest to understand the universe from its earliest moments to the possibility of life elsewhere drives innovation and inspires awe. As nations and organizations step further into the cosmos, the potential to find new resources, advance science, and unite global efforts is matched by the need for responsible stewardship and involving ethical frameworks. The future of space exploration will depend on continued scientific inquiry, visionary leadership, and a commitment to sustainable, equitable progress. The central question we'll try to answer today is how might future breakthroughs in space propulsion or research extraction reshape humanity's potential to live and thrive beyond Earth?
All right, thank you, Cyrus. And for those of you who might not know me, I'm Elizabeth, and I'm also one of the research directors for the FPS Student Advisory Council. On behalf of Future Problem Solving, I'm honored and excited to introduce our panelist today, Dr. Meganne Christian. Thank you for taking the time out of your busy schedule to talk with us today. So she'll be discussing her experience with space exploration and the future of the field. We've reviewed the questions that you all have submitted, and we have compiled a list for our question and answer session. If any new questions arise during the session, feel free to put them into the chat, the Q&A section, and then we'll try to answer them if the time allows.
Okay, so before we begin with the Q&A, we just like to give Dr. Christian a brief opportunity to introduce herself.
Yeah, thank you very much for having me. I think the most relevant point here today is that I am an FPS alumna. I did future problem solving all throughout when I was in high school in the teams competition. And since then, I've been evaluating. So I'm very excited to be able to be here and talk to you about this topic of space exploration. So I am Senior Exploration Manager Commercial at the UK Space Agency, and I'm a member of the Astronaut Reserve with the European Space Agency. But my background is actually in materials science. I spent a number of years working at the National Research Council of Italy doing materials science research, and I spent a year in Antarctica doing climate change research. So that's me.
Thank you for the introduction. Okay, so without further ado, we're going to jump into the questions you all submitted. And like Elizabeth mentioned too, if you have any questions that come up, feel free to put them in the chat for us. Okay, so to start things off, maybe just generally, we'd be interested in hearing if you could briefly share your experience with aerospace, space exploration, specifically what drew you to this expansive field and what has kept you engaged with it?
Great question. It's a good icebreaker as well, because I can kind of explain a little bit about how I ended up here, and it's not necessarily what you might expect, because I certainly didn't study anything to do with space originally. I was one of those kids at school that kind of changed their mind every single day about what they wanted to do with their life. But like all of you, I really enjoyed problem solving, for one thing. Maths and science were some of my favorite subjects. So I ended up doing a Bachelor of Engineering in industrial chemistry. And then I went on and did a PhD on nanomaterials for hydrogen storage, so for fuel cell vehicles, nothing to do with space yet. And then I wanted an international postdoc, so I moved to Italy, the National Research Council of Italy, and I was working on a material called graphene. And that led me to do a couple of parabolic flights, actually. Parabolic flights are the best way that we have on Earth to test something in weightlessness. And that's because the material that I had was being used for coatings for cooling devices and satellites. So it has to work in conditions of weightlessness. So that was my first little experience of anything to do with space. And then, as I said, I spent a year in Antarctica doing climate change research. I was at Concordia Station, which is one of the most remote places on Earth. And it's also called White Mars because it's the closest thing we have on Earth to what it would be like to do a mission to Mars. That's because you're isolated, you're in an extreme environment. extreme because of low temperatures and that kind of thing. It's slightly different reasons for why space is an extreme environment, but you're confined and you're isolated with the same crew for 9 months of the year. And so that's very similar to what it would be like to go on a space mission. And also the kind of work you do there is quite similar to what astronauts do now on the International Space Station. You are the custodians of other people's work, other people's experiments, and you're implementing those, being the hands of those people that have designed those experiments. And I really enjoyed that. I enjoyed this incredibly inspiring environment, and I learned a lot about myself and the kind of transferable skills that I had. And so it seemed to me the next step was to try and do that in space. So I applied. The European Space Agency opened up applications for the first time in 13 years. And there were 22,500 applications, so I was not at all expecting to get through. But somehow I did, and ended up in the class of the 17 of us that were selected for this class. That's how I ended up here.
Okay, thank you so much for the introduction. Our next question, which is also pretty popular, is which emerging technologies do you believe are most significantly reshaping the future of space exploration, and why?
Yeah, I think there are a lot of them. And I guess I didn't quite finish my intro because you'll see up in the top corner there it says UK Space Agency, which is not the European Space Agency, but the UK is part of the European Space Agency, even though we're not in the EU anymore. Complicated, but we're still a member state of the European Space Agency. And since I'm not a full-time astronaut, I'm not employed by the European Space Agency, I could continue with my normal job, but I wanted to get more into the space sector. And so I got a job at the UK Space Agency, and I'm working in the exploration team. And the reason that relates to this question is that we did recently a roadmap exercise to kind of think about the future technologies that are important for space exploration. And I have them here. So things like advanced manufacturing, things like AI and autonomy, communications and mission operations, in situ resource utilization, life support and crew performance, navigation and sensing, propulsion, robotics, sample curation, science instrumentation, and space nuclear power. And if I were to pick just maybe 3 of those, I would probably say in situ resource utilization, because if we're going to live on other planets, on the moon or on other planets, we're not going to be able to take everything we need with us. And so we have to find a way of using the resources that are available. So extracting water from the lunar soil, for example, or using the lunar soil to construct buildings. So that's one thing. I think another thing is propulsion, because we can only travel at a certain speed at the moment. And if we want to go further and further afield, we're going to need to increase that. So we're going to need to have better propulsion. And I think my third one would be space nuclear power. So that's related to propulsion. You can use nuclear energy for propulsion, but also when we're on the surface of the moon or planets, I think we're going to need to use nuclear power. So for example, on the moon, you have 14 days of sun and 14 days of darkness. And so you can use solar power to a certain extent during those 14 days of sun. You'd have to have really good storage to be able to continue to use that during the 14 days of darkness. So what you need to supplement it with is probably some kind of nuclear power. And so I think that's one of the other technologies that's going to be really important.
Interesting. I'm just curious too. Some students mentioned terraforming. Do you think that's like scientifically feasible, even necessary for humans?
I think it depends what we want to do. I don't think it's a short-term goal of ours to terraform another planet. I think it's potentially feasible, but it really depends. If we're going to another planet to explore it, to spend time there but not to stay there, then I think it's not something that we necessarily need to do. I think we need to build really good habitats, but there's the expectation that the people there will be returning to Earth. If as a species we decide that we want to live on other planets, then we're going to have to adapt either ourselves or them to how we can live. Yeah, I'll leave aside my personal views on that one, but so I think it really depends on the goal of the exploration. And I think in the short term, I think terraforming is not something that we necessarily need to do.
Okay, I can jump in with the next question then. Some students are also curious, so we've heard a little bit about the positives like space-based propulsion, the possibility to extract resources from other planets. Are there negatives too? Maybe ethically, geopolitical conflicts. What kind of negatives are there to space exploration?
Yeah, there certainly are. And again, this depends on what we're doing and why. So there is the potential for geopolitical conflict. I think in just 2 days ago, France released its space strategy, and which basically says that more or less says that the next war will be fought in space. So there is certainly a geopolitical aspect that if we don't go down the path of international cooperation, then it could be very, very much the opposite. So that is certainly a danger. In terms of ethics, we need to think about how we're behaving in space, whether we're doing it ethically and sustainably. So in the example of extracting resources, what does that mean for that planetary body? Does that planetary body need them to continue in the way it is? Is it going to have an impact there? Is that going to then have a trickle-down impact onto Earth? There's also the aspect of the cultural aspect of, for some cultures, the moon is sacred. And so what does it mean for humans to be going there and leaving our rubbish there and that kind of thing? So there are lots of different aspects that we need to think about, not just positive, but also things that we need to improve as we head to outer space.
Okay, thank you for the perspective.
If I could, just for a moment, Dr. Christian, you had mentioned earlier about exploration, because I think it's important to distinguish between colonization or terraforming, but what is the role of exploration in the future of space that you're looking at?
Yeah, for me, exploration is going out and exploring, discovering, learning more about our solar system, and eventually about other places as well, other star systems. Though that's a very, very long way down the track. So for me, it's discovery. It's not so much about colonizing. I mean, that's a different thing. I think first you explore, and then if you decide to go down that line, then you'll colonize afterwards. But the exploration is these kind of initial stages for me.
Okay. Next question is one also a couple students were curious about, and that is commercial space flight. So we're seeing the rise of some commercial companies, and students are curious, like, how will that kind of interface with government agencies in the future and define the future of space exploration?
Yeah, it's an important question because things have evolved a lot since the beginning of space exploration, when it was really just governments who were doing it, who were doing everything in-house. It's evolved since then, and there's a lot more commercial procurement. So governments will decide what they want to do and then put a contract out to industry, and the companies will then fulfill that contract. So this is kind of something in between. Then you could go to the other end of the scale where there's no involvement of government at all, and it's just companies that decide that they want to explore, and so then they go and develop and explore themselves with nothing to do with government at all. So there's this full spectrum, and at the moment we are mostly sitting in the middle of that. So mostly agencies will decide that they want to do something and they'll put out contracts, and then it will happen thanks to industry. And this has been generally really positive because it means that prices have been able to go down. So for example, SpaceX being able to have reusable rockets, that has meant that the price of exploration has gone down a lot, which in turn opens up access to space. More people are able to go to space. More people are able to send things to space. Of course, this has its downside as well. Regulation really needs to keep up with that so that we can make sure that we're continuing to do this sustainably, like I said before. So I think going forward, there's a place for fully commercial exploration, but it needs to be regulated in some way, in such a way that there can be a discussion among humanity about how that should be done.
Okay. And I guess to follow up on that, as we have more people going in space, will there be more conflicts on resources like lunar ice, and is kind of regulation the solution there? Or how do you think that kind of conflict will play out, and who exactly owns these space resources?
Well, who owns the resources is an interesting question to start with. By the Outer Space Treaty, no one can own the moon or another planet or an extraplanetary body. There is kind of a loophole there that you can use the resources that are available. But as we head towards perhaps extracting resources for sale, then that needs to be understood really well. And we'll probably need new treaties in place to understand how that can be done. And so treaties are a really important way of making sure that this is not conflict. And the way treaties work is that governments sign them essentially, and then it's the responsibility of the individual governments to then enforce that within their countries. And so the government will be punished if something goes wrong. It's not directly that, for example, a company, if the company does something wrong, it's actually the government that will be punished. So it's in the best interest of the government to make sure that their companies are doing the right thing. And so these treaties are a method of kind of mitigating any kind of problems that might arise. And so that's it. Space law is a really important area, and it's going to increase as we think about extracting resources, and how we're going to, what kind of treaties will we have in the future, and how will they be enforced?
Okay, just something to look out for all our competitors in the next decades. Now, I guess we've been talking about a lot of the macro scale government agencies, now going back to the individual. So students are kind of curious, like, are there long-term effects of being in space, like radiation, microgravity on the human body, and are there technologies designed to mitigate these effects?
Yeah, absolutely. So we know from the past 25 years of continuous human presence on the International Space Station for 6 month or even longer missions that there are a lot of effects on the human body. And there are the radiation effects even at the International Space Station, which is only 250, 300 miles above the surface of the Earth. If we think about going further into space, that radiation is going to become even more of a problem. If we're thinking about working and living and working on the surface of the moon where there's no atmosphere, that's going to be a big problem. So radiation is a huge one. And there's a lot of research going into what can be used as radiation shielding. The best way we know currently is water. Water is a really good radiation shielding, but you can't really put a whole, a 1 meter wall of water in front of you all the time. So how else can this be done? Technologies perhaps like hydrogels. So I spoke about working on graphene before. Perhaps you can have some kind of graphene material with water impregnated inside it that could be radiation shielding, and then all sorts of new materials. But interestingly, in the Artemis 1 mission that went around the moon, some of the biggest work that they were doing, apart from the technology demonstration of being able to do it again, was having these mannequins inside that were measuring really carefully exactly how much radiation each part of the body was receiving And so that's the first step to be able to work out what we then need to do for that shielding. So radiation is one really important one. Then just the fact that if you're spending a long time in microgravity, you're losing bone density because you don't have any, your legs, for example, they're not working, there's no impact. So your bones feel like they don't need to be working anymore. So they start to dissolve essentially. You also lose muscle mass because again, you're not working against gravity anymore. And your heart is a muscle, so you lose cardiovascular fitness as well. Your heart decides to atrophy essentially because it doesn't need to work very hard. And in that case, what you really need to do is spend a lot of time exercising. And so astronauts on the International Space Station spend 90 minutes to 2 hours every day, 6 days of the week, doing exercise. And until now, that has been absolutely the best way of being able to counteract that and the complications that it leads to. Because yeah, okay, you can lose muscle mass. What's the big deal? These kind of things can also lead to other complications like diabetes and kidney stones and so on. So on the International Space Station, it's okay because there's quite a large area and there are a range of devices that can be used for exercise. But what about on a smaller station, for example, the Gateway that's going to be orbiting the moon, or a small spacecraft that's going to be going to Mars? How do you fit the kind of exercise device that you need into a small amount of space? So the next generation of exercise devices are being made. And I've had the opportunity to test one of them in parabolic flights, actually. There's a UK company that's hoping to have their exercise device on Gateway. And so it's all about trying to do a whole lot of exercises in a small amount of space. And that means impact exercises as well. So running or jumping or something like that, but also weights training. So that's another one of the big challenges.
Okay, that's super cool. I guess now maybe zooming in even more. Some people are concerned about accidental contamination events, maybe at the microbe level. Kind of what regulations are there around that, and how might we go around broaching that issue?
Yeah, this is an important one as well because there's a big area called planetary protection, and this goes both ways. So what are we taking to other planets and what are we bringing back? Until now, we don't know whether there's life on other planets, but we know that there could be. And so if we're taking our own microorganisms there, they're going to be contaminating that environment and they're going to be changing it. So firstly, that means that the information that we get when we explore, when we research there, is going to be contaminated. It's not going to give us the right answer. It's not going to give us the true answer that we're looking for. But then what if we bring samples back and there are microorganisms from another planet there, and what are they going to do to our systems that have never had any exposure to that kind of thing? Could it be some kind of superbug that causes problems for health? It could be some kind of pandemic again. So it's a big question, and we have to make sure that anything that we send is as clean as possible. And when we bring samples back to Earth, they have to be contained, they have to be kept in glove boxes until we have a perfect understanding of what is inside them.
Okay. And I guess maybe now taking a step back, students are curious, like maybe in the next 10, 20 years, what do you think is the future of space exploration? Will that, I know it's far out in the future, but maybe some predictions on kind of where we'll be standing in that field.
Yeah, well, I mean, the next few years, starting there, we're going back to the moon. This time, not just to go, but to stay. So we'll see the Gateway space station orbiting around the moon, and we'll see the first missions, the first set of new missions to the surface of the moon. And then I think 10 years down the line, we will start to see there being stations on the moon, a bit like we have in Antarctica. So research stations on the surface of the moon where people go and live for maybe a month, a couple of months at a time. And then they do research and come back. Then I think concurrently, so in maybe 15 years, we'll start to see humans going to Mars and coming back again. If we go down the kind of track that we have so far, the first mission will probably be a flyby. humans going around Mars and coming back again, giving us all the information we then need to then have a landing on the surface of Mars, which is huge. It might sound simple, but it's hugely technologically challenging, especially when you think about the fact that of all the spacecraft that we've sent to Mars, only about 40% of them successfully land on the surface. So if then you're thinking about sending humans there, we need to get that percentage right up to almost 100. So there's a lot of development that needs to be done in the meantime. So that's why I say that's probably in the 15 to 20 year down the line. In 50 years, I think we will have regular missions to Mars. I say regular, but they can only go every 2 years because of the way the orbits of Earth and Mars go, but semi-regular missions to Mars. And I think we probably will have some research stations on Mars as well. And we'll be starting to think about other destinations. So perhaps some of the moons of the gas giants might be something to think about, depending on the results that we get from some of the missions that are happening at the moment, like JUICE, and what they tell us about what these moons, whether they might sustain life. Because I think the biggest question for us is, are we alone? And so a lot of space exploration is about going out and trying to work out whether we are. And if we're not, then that's going to be an interesting change in the way we do things.
Yeah, I remember maybe a couple months ago, James Webb found some traces of life on other planets. Do you think that's possible to, like, in the next, I don't know, 20 years? Do you think we'll find traces of life? I know it's very hypothetical, but I'm just curious.
Yeah, it's hard to say. I think we're having an increasing cadence of stories like this, of there being something to indicate that there might be life. And I think with the more and more powerful telescopes that we have, for example, that I think it will become more and more possible. And then there's one called Habitable Worlds Observatory that will be coming in the next 10 years probably, which will be specifically searching for life elsewhere. And so I think we're getting there. It's impossible to say when it will happen. At the same time, the rovers on Mars are starting to have small discoveries that could indicate, amino acids, this kind of thing that could indicate that there was life, not necessarily that there is life now, but that there was life in the distant past. And so I think if there was, we'll have conclusive evidence of that in the next 10 years as well.
Okay. I guess maybe we'll continue one last question about space exploration and may transition more into kind of how your experience, especially in FPS, helped. So to kind of wrap things up with this topic, we're just wondering ethical issues. We touched on this a little bit, but maybe with international partnerships or any type of ethical issues, maybe that you've encountered just in general about space exploration.
Yeah, I think for this, we have to kind of look at the history of space exploration. So it started as a race. It started with the space race between the US and the former Soviet Union. And in the context of the Cold War and everything that was happening there. But then it also helped bring them together. So there was the iconic moment of the Apollo-Soyuz mission, where an Apollo and a Soyuz, so Apollo was a US capsule and Soyuz is a Russian capsule, they docked together, and the astronaut and cosmonaut on board reached through and shook hands. So I think that space can be a brilliant example of international cooperation, and I think that's what the International Space Station has shown as well. But unfortunately, we are coming to a point where we could regress to that kind of conflict, that space race that we've had in the past. And there's kind of talk about that at the moment, especially with regards to China, for example, and who's going to get there first, and is there some kind of military advantage to being the first ones to go back to the moon? And then even though you're not allowed to by the treaty, the Outer Space Treaty and the Moon Treaty, even though you're not allowed to own parts of the moon, there are some ways that you could perhaps get around that. For example, if you're putting a nuclear power station on the moon, then by another part of another treaty, you're supposed to have an exclusion zone. So that effectively means that you own that part of the moon because you're excluding everybody from it. So there are these kind of loopholes that I suspect will be used. And so I think we really need to come to a point where, a bit like Apollo-Soyuz, we're doing this together rather than apart. And if we are doing it together in international cooperation, then that makes it much easier to address ethical issues like cultural heritage and what it means for humans to be going further afield, and really kind of sci-fi ideas like adapting the human body to living in outer space. That's kind of a discussion that we have to have. Do we want the human race to evolve in that way? Can we force it to evolve in that way? Is that possible, and should we do it? These are the kind of conversations we have to have as a human race, and I think we can only have them if we're doing it with international cooperation, and also cooperation between the private sector and the public sector.
Right, absolutely. Yeah, those are definitely some important ideas to think about. So these questions are going to be more focused on like your day-to-day job. So how has future problem solving maybe impacted your journey as a senior exploration manager and reserve astronaut for the UK Space Agency? If you could just give us a bit of details on that.
Yeah, I think future problem solving is a huge part of my life. I think it was it gave me the foundational skills that I needed in every aspect of my life. You know, the 6-step problem solving process is something that you can use when you're at uni doing an engineering degree, as I did, for example. You can use that. You can use that in research. And then you can use it when you're putting reports together, like I have to do in my everyday work. And as the thing I find especially useful is the structure of the underlying problem, and just thinking about getting to the bottom of what is the underlying problem here, what is the biggest issue, and what do we need to do to solve it. So I think that very sort of prescribed way of going through the problem solving process is something that I've been able to use in everyday life. But there is that prescribed there is that kind of that structure, but at the same time it allows for a whole huge range of creativity. And so I think the encouragement of that creativity that FPS provides has meant that I was able to apply that to my research as well. So firstly, thinking about a whole range, like what kind of categories can we use for this? But also that's to kind of start the initial brainstorm. But then thinking systematically after that, what are the steps that we need to go through? And so I think it's hard to put into words because it's just been something that I had ingrained when I was quite young, that I can constantly use in any aspect of my life.
So yeah, absolutely. FPS is definitely also like very important to me as well as a future problem solver in global issues and community problem solving. So this question kind of targets more about like the categories in future problem solving about business. So what kind of new businesses do you think might emerge with the rise of space exploration? And then maybe how will this kind of shape society and the future of societies?
Yeah, I think the thing is that it's so broad. So there are so many different areas that we need to address as we go forward with space exploration, and many of them are technological. But I also spoke a lot about space law, and also there's the whole human side of things, and how to help humans adapt when they're going into outer space. So there's a kind of psychological side of things as well. So and then as we go further, who is going to document what we're doing, and how is that going to be documented? So there's kind of an arts journalism aspect to that as well. So I think there will be companies that spring up across all those different areas as we go further. And there will be companies that spring up in areas that I can't even think of today, that hopefully you will think of when you're writing your booklets.
Yeah, absolutely. I totally agree with that. So we've been really focusing a lot about like human impacts on space exploration. So we're going to transition more into this question about AI. Do you think or do you believe that AI can impact space exploration in any way as it has done in other fields like medical, literary, marketing?
Definitely, and it already is. But just thinking of perhaps the simplest example is if we're going on a mission to a destination that's quite far away, you have a time lag. So, for example, for Mars, I think it's anywhere from about 9 minutes to 20 minutes, depending on where we are in the orbit. So that means that you really can't, if you're controlling it from the Earth, you can't give real-time commands. So AI is absolutely necessary to be able to for propulsion, for deciding where to land, that kind of thing. It can be pre-programmed, of course, but then to solve problems as they arise, make last-minute decisions, that's going to be the domain of AI. Also, if we think about the human aspect, if we don't have a doctor on the crew, or if the doctor is incapacitated, we're going to need some way of solving problems when they occur in terms of health, also psychological health. So there are systems being developed using AI as a kind of AI doctor as you travel to Mars, for example, with huge repositories of information, but then using the AI to diagnose and to come up with treatments. And then you can connect that system to something that's perhaps 3D printing pharmaceuticals, which sounds crazy, but it is something that people are working on. So you can connect these kind of these systems. So they're just two areas of many that AI is going to kind of conquer.
Oh yeah. I've definitely heard of some like AI examples. Like I think there's the Robonaut 2 and then like Simon. So that's
Simon,
definitely very interesting.
yeah, Simon is one of the experiments on the International Space Station that is kind of an AI companion for the astronauts. So giving that psychological support, but also being able to do certain tasks to help the astronaut out. So I think the future is definitely going to be working humans and robots together, rather than one or the other.
Yeah, that's really cool. Yeah. All right. Our next question is about climate change. So, will space exploration be able to help with mitigating problems related to climate change, especially with like the rising pollution percentages on Earth?
I think if we loosen the definition of space exploration, then yes. So it's our work in space is already fundamental to our understanding of climate change. So there are a certain number of variables that we monitor for the climate, and more than 50% of those can only be measured from space. So many of the satellites that we have in orbit are monitoring our Earth, and they're giving us key information about climate change. So I think in that respect, space, we can't really do without it. We can't conquer, we can't mitigate against climate change without having our space assets. Thinking a bit more abstractly, going more onto the side of exploration rather than just space in general, if we manage to explore other planets, for example, Mars, and get a good understanding of what has happened in the history of Mars, why it lost part of its atmosphere, for example, then that will give us more of an understanding of what the future of Earth could hold. And so understanding other planets will help us understand our own. And of course, part of that is climate change.
All right, yeah. I know you mentioned, kind of looking at the history of other planets and objects in space. to kind of understand our own planets, right? So what are some consequences of space exploration that could affect us as a human population and the Earth in general from these research and findings?
Yeah, I mean, I think the biggest one is probably what I was saying before. Are we alone? If there is life out there, then I think that will really change our way of thinking. I think it will. I think it could unite us as a planet, and unite all the people of the world, because it's not just us fighting against each other anymore. It's us together, and there are others out there that we will hopefully cooperate peacefully with. So I think that's one thing, but also that understanding better the past of other planets and the future of ours, and it will have a huge impact on how we go about our lives. If we find that something happened to another planet because there was a certain number of degrees of warming, in that case naturally, if we do that to our planet by man-made means, then that's a big deal. So it doesn't just have to be, something's happened because of life on another planet. It's might have happened naturally, but if we accelerate that on Earth, then things could be disastrous. So those kind of understandings are important.
Okay, yeah, I agree with that. This is a question from the Q&A, mostly about like life and habitability. The question is, how can we study the potential for life on exoplanets and determine if they have liquid water? So maybe like if there are any chances for other organisms that are living out there, or if we can use these to our own advantage.
Yeah, I'm not an astrophysicist, so I'm not an expert on this. But basically, there are a few ways of detecting exoplanets, and it's usually by taking the spectrum of the intent and the intensity of light that you're getting of a star. And then when that intensity changes, then there's an object that's moved in front of it, and you can kind of test the periodicity of that to understand if it's something orbiting. And so this gives us an idea of whether there's a planet orbiting that star, and then you can think about the distance from the star as to whether it would be habitable. So there are those kind of physical parameters, but then you can also get a spectrum of the kind of gases that are in the atmosphere of that planet, and that gives you an idea of whether it's habitable as well. Like I said, I'm not an astrophysicist, but that's the only thing we can really do with exoplanets at the moment, because there's no way that we can go out there ourselves, or even send a probe there. We can, but it'll take many, many years to actually get there, and then to be able to send back that data. So there have to be these kind of indirect methods of detecting them.
All right, yeah. We're going to transition more into technology questions now, based off of the responses from the Q&A again. So how quickly do you think that the space-focused technology will expand and develop over the coming decades?
I think it will expand faster and faster. Perhaps not as fast as the science fiction authors of the 60s and 70s would have hoped. But I think we are at a moment where there are more and more companies working on this, and the prices are coming down, like I mentioned, with launch. So I think we will see an expansion, just like we've seen an expansion in computing, for example, over the last 20 years or so, 30 years. So I think that kind of expansion will start to happen, and has already started to happen in space as well.
Okay. That's amazing. All right. Okay, our next question is kind of a more, we're stepping back and kind of a more general point of view. In what ways do you think that space exploration can give us a better understanding of our Earth, whether that's like resources or like the human population?
Yeah, I think it's mostly what I've talked about before. So directly monitoring our Earth from space, also drawing conclusions from what we learn about other planets and what that might mean for us on Earth. But I think there's also a kind of philosophical aspect here. So it was really the Earthrise photo and a combination of the Earthrise photo and the pale blue dot. So the Earthrise photo is the one that was taken on one of the Apollo missions. I think it was Apollo 8, of the Earth rising behind the moon. And that really kicked off the environmental movement. And so I think there's this kind of philosophical aspect of the way we do space exploration. And the pale blue dot is the one of just this tiny little Earth that you see just all by itself in the blackness of space, taken from a spacecraft that had gone that was heading out really far out into space. So these things make us think about our planet in a different way, and how fragile it is and how much we need to protect it. So as well as the kind of the discovery, what we learn about the Earth and other planets, there's also this aspect of philosophy.
Oh yeah, definitely. And I've seen the Earthrise photo myself. It is definitely absolutely very beautiful. I also really like the blue marble image. I think, that makes me feel like, wow, Earth is super cool. Um, okay, so here's we're gonna start wrapping up the questions, but we have one last one from the chat, which is asking, have you ever been into space before? Maybe what did it feel like? And what would you say to someone who is interested in space or space exploration beyond just future problem solving?
Yeah, I haven't been to space yet. So I was selected in 2022, and I'm a member of the reserve, which means there are no guarantees, unfortunately, that I'll get to go to space. But I have started my training, and two of my fellow reserves have already had missions. So it's quite possible. The odds are in my favor, so to speak. So hopefully it will happen in the next 5 years or so, 5 to 10 years. And I will be able to tell you what it's like. I mean, I can tell you that every astronaut that I've spoken to has experienced what is called the overview effect, which is when you look back at Earth from space, you see it not like you see on the page where there are borders and boundaries between countries. When you look at Earth from space, you don't see those, and you see just how much that we are all in it together. And so there is that philosophical aspect that I spoke about before, and that has hit every astronaut that's been to space before. So it's really a special experience. In terms of wanting to get into this sector, well, it really depends what you want to do. As I said, there are a whole range of areas that space is going to be expanding into the future. So, for example, that space law that I talked about, but also many different aspects of documenting and the artistic side of space. So even if you're not oriented towards maths and science, there's probably a space for you coming soon in the space sector. And so I think the key is to follow things that you enjoy and are passionate about, and getting involved in extracurricular activities like FPS can definitely help you. And I think it did, being an FPS alumna, definitely helped me in getting the scholarship that I had to go to uni. And then that helped me along the way during getting jobs and so on as well. So I think it's something that you can always pull out. And so follow your passions, but remember that you don't necessarily have to follow a traditional career path. You're not trapped into any one career path. So make sure you're listening out for any opportunities that may tempt you. I never thought that I was going to go to Antarctica. I never thought that I was going to apply to become an astronaut. So just look out for those opportunities. And if you are tempted, be brave enough to take them.
Absolutely.